Hey, welcome to this. Well, I think it's the last session of today, at least, day six in Global Hack Week. And no, I'm lying. I'm totally lying. We still having one more, which is Rosendo. We is still have Intro to Google AI Studio with Rosendo tomorrow at 11 a.m. It will be 1 hour session. So don't miss that out before our closing ceremony. Right. So another thing before I forget, because I always forgot to do this, don't forget to check in this link, eventsmlh.io/events 1292, so you can win your community points. And now that said, let me welcome you to this data pipeline session. I was just finishing a previous stream about Kaggle competitions, right? Data competitions, in which we made use of some of these techniques. But I wanted to give a more beginner friendly session for you to understand the data workflow, right? So let's jump into my slides I have prepared for us and in the content of the session. Also, I'll be checking here the comments, so if you have any question at any time, please feel free to drop it here at the comment section, and I'll be checking that out. Um, you should see my screen right now. Oh, I didn't add it. Sorry. Here we are building your first data pipeline. My name is Alberto Camarena. Sorry, I always forgot to introduce myself. That's why I put it here in the opening slides, right? The workshop is data pipelines, and today it's 17th of December. Sorry, September. My bad on that. It's late for me, so I'm kind of being sleepy right now. So the learning objectives is to understand the core principles of a data pipeline, um, that being the learned ETL process, extract, transform, and load. Currently, there's another framework that it's extract, load, and then transform. That's ELT. But the regular one that you are going to see more often, or that you are going to perform more often, it's ETL, extract, transform, load. So if you have seen these, for example, in job application before, but you didn't know what it was, well, now you will know what it is. Perform hands-on data cleaning and exploration. Again, I already covered a series of 3 sessions doing this in a competitive and more professional way, but the intention of this session specifically is to do it beginner friendly, right? So if you missed out the previous streams, don't worry, you can check them out at GHW.mlh.io. That's the Global Hack Week page, and there you can find the recording for the previous streams and a link for our YouTube channel. So perform, sorry, I already read that. Build a simple and predictive model for cleaned data. So again, we already made that, but we are going to take this really slow. I'll try to explain all things not only in the code terms, but in statistics, in mathematical, and also I'll be really happy if you came up with questions here in the comment sections, because sometimes when you are like used to doing these kind of things, you forgot something. It's not how to say it. It's not that common, or that someone else can have that question, and that will be a great approach for you to the session. Why learning data pipelines? Well, data pipelines make data reliable and accessible. So maybe I mean all applications in hackathons, in professional way, everything generates, handles, and generates and manages data. How we do this, it's the key difference. So we probably are creating or are working or are having an application or a system that has some data insights, and we are storing them, but we're not using them. Or probably if we are not even storing all data that we could, or probably we are not doing the right analysis on it. So data is everywhere. So this is important to us for understand that data makes everything, uh, if we treat them respectfully and in a good way, better, right? So the data pipelines make data it's reliable and it's accessible. So it's a matter of respecting the data, right? Also, the data pipelines ensure that the data is clear, consistent, and usable for future analysis. And its future analysis could include machine learning, right? Helps automate repetitive tasks. We are going to talk about data ingestion, data cleaning, and data storage, right? But don't worry, we are going to cover that. Also, it provides the foundation for the analytics. Right now, I've seen a lot of companies and a lot of people talking about AI and AI this and AI that and the long language model and generative AI. And to be honest, I'm kind of sick. Uh, More because they talked as AI as a service and not as what it truly is, which is statistics, analytics, data. So having good knowledge of where the data comes and having strong fundamentals of these, for example, data pipelines will make the true difference from an engineer that wants to take AI seriously or just as a hot topic on social networks, right? And that's my take on that. So key pipeline concepts to keep in mind. First, it's the data sources. This could be your application, some data set, some database that you have access to, public APIs, some logs generated again from your application, things like that. The ingestion layer. So we need to move data from one place to another. That's the main pipeline idea or concept. Then the transformation. So here we are applying modifications to our data. They clean, reshape, enhance, scale, normalize, these kind of things. Then the storage of the new data, maybe in a data warehouse, data lakehouse, or directly to the database, right? Consumption, because we need to do something with this data, right? We don't just want it because it looks pretty in our, I don't know, in our database or something like that. We want to consume it and do analysis on it, generate uh, insights, create some reports, some visualizations, like in these BI dashboards, something like that. So the overview of the ETL, extract, transform, and load, looks like this. The extract, for example, put the data from the source. Again, it could be a CSV file, some JSON format, an API, directly the database, your application, etc. Then transforming, cleaning it, joining it, making some aggregations, some queries, creating some features about it, right? Sorry, not the queries. I forgot. I confused the words. Um, and then to load it or save the processed data on your desired target. Again, this could be warehouse, lakehouse, or database. What's the difference for warehouse, lakehouse, database? Well, mainly just how we structure the data. For example, in a warehouse, the data is already structured, are ready to consume. I do think a good recommendation is how you have one database for like cold storaging. Not moving the data in it, and another is which will be the warehouse to exactly be consulting, deleting, modifying, and things like this, and also the saving the processed data generated from this ETL. And the lake house, it's you just draw information in there. You don't uh, actually have a how to say this an structured way or an fast querying for it. Um, so that's the difference between these three. The ETL in short terms, then it's the brain of the pipeline, and it helps ensuring that the data is accessible and usable in future terms. The dataset overview that I have prepared for this specific session is this one. Um, I think I forgot to add the link, but it's called Intro the Data Cleaning, EDA and ML, and you can find it on Kaggle. I have it here. The author is Walik Watambiti, Leo Philip. So this is a really, really short database. I think it consists of only 73 or 75 entries. And the main intention of this is to help us understand the process of cleaning and transform, all the pre-processing, the EDA or the exploratory data analysis, and then just build a simple analysis around it. In this case, we were using a classic machine learning model, which is really simple, and I will try to explain this as bad as I could. But machine learning, it's not necessary. I mean, we could run simple statistics about this. Um, find the mode or the most repetitive value of, I don't know, an entry, um, trying to predict with linear regression values, some things like that, right? Again, not necessarily machine learning, but hey, machine learning is a hot topic. So, well, AI, it's a hot topic. So let's introduce or let's talk about uh, artificial intelligence and machine learning, but in a serious way, right? It contains multiple CSV files with tabular data for demo. Again, if we come back again here, we are going to see the BI CSV and this other intro to data cleaning and machine learning HTML. We're going to use just the BI. So the first step, and don't you worry, I am going to cover this first theoretical with the slides and then go to Visual Studio and open a Jupyter Notebook to run this interactively and explain deeper, right? The first step is to load the data. Thankfully, if we are Python users, there's a library that can help us doing these kind of things in a really, really simple way. And this library, it's called Pandas. I'm going to open here as well the documentation of Pandas. So we can see Pandas, it's an open source library providing high performance, easy to use data structures and data analysis tools for Python programming language. So you can find that the documentation for Pandas, it's really simple, but mainly we're going to use it for the data structures, right? And one of the great things Pandas have is that it has the read CSV. This function, it's like the first step in every data analysis. Load the data. We first need to have access to the data, and it is really, really great when we need to access big amount of data. Again, in this specific example, we have a count number of oof, I think it's again like 71 or 70 something values. So if you come from other programming languages, you will have to know that some data structures are not that great for managing big amount of or big sizes of values, right? In this case, pandas create one thing that's called a data frame. That's why we call this DF. Uh, a data frame it's a type of of data that it's like a table that we can access rows and columns, and we will have each row as an entry and each column as a feature. So this is also great tool for you to start understanding some of the lingo that's commonly used in data analysis. So the first step is as simple as one line of code. Data frame, it's the structure or the type of data we get from reading a CSV value. If you don't know what a CSV value, don't you worry. A CSV value it's a comma separate value file. And what it means it's that you will see something like this. For example, name, comma, age, comma, ID, and then another row, Alberto, comma, 25, comma, 1, right? Because Alberto is my name, 25 is my age, and 1 it's the ID because it's representing the first element in this sample um, example I am giving. Other format that it's commonly or common to find resources, it's for example JSON. So in JSON, which is a file called JavaScript object notation, we have things like keys and values, where each key it's a string and a value could be something like an array, something like another object, a nested object, and a string, a number, things like that, right? And well, that's the data structure, and it will be treated differently. So for example, if we return to the pandas documentation and we check the user guide, and we probably can find a section about 10 minutes to pandas, into the data structures, essential basic functions. Here in the section basic functionality, accelerate, blah, 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 sorting, copying, data types, no, into the data structure, series, no, I wanted read, and there's probably the read CSV, read Excel, because yeah, we know some of our companies have this, like you are generating data or your main data the database it's on Excel. Feather, I don't know what the format is for that. If WF again, for example, from an HTML or for JSON, right? Org, parked, pickle, SAS, SQL, for example, if it comes directly from the SQL database, a table, an XML. You see, there's a lot of formats. So again, Pandas, it's great because of that. It helps manage all that typing. But one of the standards, because it's pretty lightweight, it's also very efficient, I'll have to say, it's this read CSV, right? So that's what a CSV is. Then this is just a string that it's the path to your file if you have it locally, or if you're downloading it from an API. For example, if you're using the Kaggle um, SDK, well, you can download that directly from the Kaggle database. And in that case, they even have some the function have an an option to import it as a pandas table or data frame. Sorry. And well, that's the start here, right? So the first step, just this line. The rest, it's helping, for example, import pandas. We need the library, the comment. And one thing I recommend you to do, it's do something like this. Preview the first rows for you to understand what's happening here. Because yeah, sorry, Kaggle, it's great because it shows something like this. And you will see something like this in your project, giving you the first values, the column names, the values of it, some statistics. Well, that's because Kaggle is great, but not all of your data sets will come with that visualization. And here it's how you can do that manually in Python, right? We will see that more interactively again on the Jupyter Notebook once we reach that point. So the objective of this step one is for you to understand the data structure and the types of the columns, and you can also perform more things for understanding the full information of the database you're or the data set you're aiming to. Then we need the data cleaning. That's the step two. It's probably very common. No, sorry, it's not. It's probably it is very common for us to understand missing values. Sorry, for us to find missing values. Sorry, I am too sleepy. I need to wake up. Um, we will find missing values in our data. We will find duplicates. We will find some features that does not give us any information, or that in general it's not important, but some with something can be really meaningful. And I'll give you an example about that. But let's go point by point. How we treat missing information. Well, for example, here we give data frame to fill non-existing values with the mean value, and this is a statistic function that what it does it's that, for example, this is if this is a numerical value, it make the sum of all of the values, and it divides the resulting in the number of elements. So that's the mean. We have more statistics, for example, the mode, which is the value that repeats more frequently in the array. We also have the mm, median, which is not about the value of the elements, but if we take the full list of the elements, it's the middle position. So it will depend a lot on how it's the distribution of our data, if we want to use one of another, and also what type of values that we have, right? And for example, if we're talking or we're converting a categorical value into numbers, probably we'll use the mode, since we don't want to have an average or something like that. We will have the most repetitive one to fill this. If you don't know what a categorical or a numerical value is, don't worry. Um, Numerical values are two: floating or integers, right? And if you do have a formal preparation in software, that probably will make you sense. Floating are, for example, 1.11, uh, 12.05, things like that. Float, it's point-based values. Integers are just 5, 6, so 7, things like that. So numerical values are easy to understand. Now, then categorical values are, for example, sex. You can be uh, male or female, or for example, you can be in categorical. directly a binary category, um, smoker or not smoker, right? So converting categorical into numerical can be as this. If you're a smoker, that's a zero. If you're not a smoker, that's a one, or the otherwise, right? Now let's imagine it's a three category. Let's think about countries, right? So if you have a data set including the number or sorry the country of a person, that will be interesting for you to take a look to the full range of countries that you have. Maybe in your data set, you don't have all countries in the world. I don't know how many countries in the world are they actually, but let's think there are around 200. You won't have to worry about 200, but even if you do, you will have to map, for example, as the phone numbers, right? In Mexico, we have the plus 52. In the US and all the US uh, countries, I don't know if that's something, but they have like the plus one, right? I think they're like fighting with Canada for the plus one. I don't know if that's a conflict or something, but Canada has also the plus one. Um, I don't know for other countries. I don't know actually. I haven't visited them to see the Lara number. But what I mean is to we need to map, for example, and decide Mexico will be the value, the numerical value one. The US it's going to be numerical value two. Then I don't know, Colombia it's going to be numerical value three. Then Brazil it's going to be numerical value four, and so on and so on. Then we need to encode that to have a map direction, right? So that's how we treat categorical into numerical. And why we do that? Because maybe there are models or there are analyses that allow us to have string or text based data. There are others that we don't, so we need to translate everything into numbers because numbers that it's all that algorithms identify, right? So that's why, and it makes sense. So that's a little bit of the data cleaning we're doing here. That will be, or that will, I will say that the last things I mentioned, that will be a little more about data transforming. So that's not purely data cleaning. So let's keep with the data cleaning. Remove duplicates. For example, df or data frame, drop duplicates in place true. That's simple as it is. Another thing we can do for missing values, it's also drop not values, but it depends on how many rows that we have. This is a good idea or it is not, because in this case we are trying to fill with the mean value. I mean, this is not the real value, and it won't be the real value if we have missing values. But for example, for our 72 rows data set, the leading theory will be like a suicide, right? We are going to just have 40 elements left, and that's too few data. I mean, it's almost nothing. It's really complicated having a good prediction or good analysis statistics based on few data. So this is why if there's a missing value, we are not deleting that, we are not dropping it, we are actually using the mean. In this case, for duplicates, duplicates do not give us information. So yeah, we're dropping this to truly see the number of elements that we have. And about the feature engineering, let me give you a more detailed example. So imagine we have a feature that tell us the number of brothers that you have, and another feature that tells us the number of sisters. So for us, that could be like, okay, I don't know why the data set comes as this. Maybe the application have that in a different form question or something like that. And some feature engineering, what the term meaning, it's that we can create a new feature based on the existing ones. In this case, for the brother and sister example, we can create a number of siblings, right? And combine these two to have a better idea. Um, I don't know, for example, well, I think that that's an accurate example, and then that should be enough. Also, I'm going to give you a better idea of how to use it in the data set we have specifically. So don't worry. Objective: transform raw data into clean and structured data. After the data cleaning is done, it's also a good idea or a good recommendation to do this again or something like that to describe the data that we have and inspect it again. The step three is to store the clean data. So in this case, as easy as it was to read a CSV file, it is to save it data frame to CSV and where we want to save our new data. The objective is to demonstrate the load step and create a persistent data set, a new data set that is already clean. Because this is something, the first, second, and third step, probably it's something you just want to run once, right? Once you have your data stored, sorry, cleaned, processed, and everything, you want to store it. It does not make sense to perform the cleaning operation every time you run your processes, right? So then we do an exploratory data analysis or EDA. Here, for example, again, we do a description of the data frame and we visualize some distributions. In this case, we use a library called matplotlib and another one called Seaborn because it's like a layer on top of Matplotlib that it makes beautiful visualizations really, really simple. So forget using things like Power BI or Tableau or something like that. You're engineers, so you use Matplotlib. Uh, I'm kidding. You're free to use whatever tools you want, and I'm really sure those two are great. I haven't tried them to be honest, so I don't want to be rude here. Um, so importing Matplotlib as PLT, df its data frame for the feature, and we are going to plot an historic for an histograph for this. Do you know what an histograph is? Well, let's open Matplotlib documentation and we will see that they have on the examples all of the charts that you can create: infinite lines, bar charts, stacked bar charts, group bar charts, horizontal bar charts, broken horizontal bar charts, cap style, plotting categorical values, plotting coherence, curves, even 3D plotting, uh, a lot of things, scatter plot, confusion matrix, stack plots, spectrums, images, control labels, heat maps, color meshes, trip color demos, watermarks in the images. Well, a lot. For example, let's look for the histograph. What was called hist, yeah. Pipeline hist. And let's see if they have an example for that. Oh, they don't. Oh, yeah, here's the histogram. So simple. It's the frequency of a value of repetitive a value is. So we will see uh, what they do and what they represent. Simple. So in this example, we are going to visualize distribution of our features with the histogram, right? And this is just a silly example. When we describe the data, and when we start taking the look to how it is structured, what it contains, type of elements that we have, we can start or we can try to play a little. And again, this is kind of the um, artistic part of the data, because we need to get some insights, and we need to start playing a lot with the values. And with time, I mean, the more experienced you are, you will start to identify patterns, correlations for these type of data more easily. At first, I recommend you to start running a lot of experiments. Think about, for example, what if I plot this feature against this other? What if I plot the distribution of the data points in a 2D map, then a 3D map, how it would look? Or I am identifying that these two values overlap on a scatter plot, so maybe I could do feature engineering for these. I don't know, things like that. For example, a box plot will tell you about the distribution on percentiles, so you can identify easily if you can use a statistic distribution as the mean, as the mode, as the median, or things like that. Better for you to pre-process your data in the data cleaning part. Um, more of this, the intention of, or the objective for this step is to understand the patterns and generate insights from this clean data. um, so the last step is to, well, in this case, again, I mentioned it's a simple machine learning model, but this could be any type of analysis. Don't you have to worry about creating or having to do machine learning for this. In this part, how a regular machine learning workflow looks like, it's you split your data in two sets. It could be three sets, but again, we have now a really reduced amount of data. The train, the the test, and the third one I usually I like to work with, it's the validate one. So you split that in, for example, in this case, we're doing 80% the training and 20% the testing. So it will give you your train set, and your training target, the test, uh, the test data frame, and the target for that as well. So we receive X and Y. You can commonly find these X and Y. The X, this is kind of interesting because in software engineering, probably you heard a lot, like, call your variables with a meaningful name, don't call it as it is. And don't call it, they explicitly tell you, like, don't call it just X, A, B, or something you didn't understand. But there is a reason, don't worry, there's a reason why this is called X and Y, and why this is a standard. And it is because you can think this as a mathematical function. And if you remember your math classes, or math segments, well, at any level you were, you probably remember equations have the dependent variable as y, and the independent variable as, sorry, dependent variable as x, and independent variable as y. So what we're trying to find here is the target function, or the thing we want to predict or to classify. Here it's the data frame target, because we are under a supervised we're under a supervised sorry, we're under a supervised framework. If you don't know what a supervised framework is, basically in machine learning there are three, but let's just mention two frameworks: supervised and unsupervised. Supervised meaning that you give the model the question, but also the result. In unsupervised, it is not like that because we don't have the results. We just give questions. So machine learning and in general, machine learning have four different applications: classification, prediction, dimension reduction, and clustering, or clustering. um, so these last two are normally unsupervised, and the first two, classification and prediction, are normally supervised. uh, there are different cases, but in general, that's how that works. The intention here again, or the reason why this is called x and y, it's because in the mathematical equation, we want to find we want to find y. We want to find the y, uh, and we have the x. That's the thing that's going to be changing every time, but that we have the values for our equation, right? So this is the independent variable, and this is the dependent variable. So that's why they are called as this. That it's not just bad naming conventions. Um, in this train test split, again, the intention is to divide our data into two sets: training and testing. Again, I also mentioned another one, which is validation, but it will depend on the number of elements we have on our data set. Why we divide these two? Well, in machine learning specifically, we have one thing called overfitting, which is that the model learns the data that you give for training, but when you face it with real world data, it does not know how to recognize, or it didn't identify the right pattern for it. So it does not have the desired outcome when it comes to that. And how we prevent it, it's with this: we have a train set and a test set. So we train it with just a small fraction of our data, and then we test it to see how it behaves with data that the model haven't seen before. Um, Random state, it's just a parameter to make sure every time these it's run, it generates the same output. I don't like to work with random state unless it's specifically required uh, for us to debug something. If we're debugging, I like to add the random state. If we're just experimenting, I do not like it because I like the randomness of the generation of every new sets, right? Uh, so again, this is not for general data pipelines. This is just a specific example, and you can change the step 5 into building a simple ML model just to apply your data, right? Do an analysis over it. Again, it could be as simple as just applying static statistics. It not necessarily needs to be machine learning model, right? Uh, Again, I just wanted to introduce this because I think we all can we all love artificial intelligence. Again, it's a hot topic, and why not, right? I think it's also a good introduction for you if you're not familiar with these kind of concepts. Then, what else is happening here? Random forest classifier and accuracy score. If you see scikit-learn, which is the okay, let's open scikit-learn. Scikit-learn, it's the machine learning library for Python. So it's simple and efficient, accessible to everybody. It's built on top of NumPy and SciPy and Matplotlib. It's open source as well, so it's just great, I'll have to say. Uh, Right. So, also, for example, I mentioned machine learning have four modes: classification, regression, clustering, and dimension reduction. Uh, Scikit-learn also help us with the model selection because it has a lot of great resources for that, and for the preprocessing of our data or doing the early data analysis that we talked before. Right. Great. So it is well structured. I have to say, I really love how scikit-learn works because, for example, for the model selection, we have this train test split. For the ensemble and in really quick worlds, an ensemble it's a method that does not use a basic model, but it's using a series or a set of existing basic models. In this case, random forest, it's a tree forest, or sorry, a tree classifier, and it's called that way forest because it uses many tree classifiers. um, Tree classifiers are simple. It's just the tree data structure, one node, two decisions, if it was one way or another. And this specific example, it's just a random forest. It has many trees like this that has different outputs depending on the features. And finally, it decides if it is one thing or another based on the results of many trees. You can call it 1, 2, 3, 4, 5, 100, 1,000. And for the metrics or for measuring, in this case, we're doing a task, which is classification. The metric for classification, normally it's one thing called accuracy, or being if you predicted one and the result is one, that's good. If you predicted two and the result is two, that is good. For things not like classification, but what was the word? Sorry, I forgot. Regression or prediction of value. Uh, how far it's your result from the desire. For example, in a function, a sinusoidal function, your value should be two, but the output was one. Well, you have an error of one, right? Depending on the task or depending what you want to do, it's the metric that you need to check. Um, in this case, well, we do a random forest classifier. We save that in a variable called model, and model already comes with the function fit, which is for training the model with the trained data. And this is the, again, uh, tag and the solution. Sorry. And the prediction, it's saved in model predict, and we don't predict nothing but test, right? And the accuracy, it's based on the results of the test and the prediction, right? So I think that's simple. I hope I explained well. And if you have any questions, remember I can answer to you here on the comments. The objective of this is to show how clean data fits into machine learning, again, or any other analysis that you want to run on your model. Let's do a little recap. Every pipeline flow looks like this. It starts from a source. We extract the information, we transform it, we load it, and then we consume it, right? Data set loaded from the CSV. We clean our feature and we create some feature engineering. We save that into a new file. We create an early data analysis for the model to consume, and that's just it, right? So some tools and resources you can use, and we are going to use for the rest of the session. It's pandas, Python, Python and Pandas, also Matplotlib and Seaborn, scikit-learn. Kaggle, it's where we get our data set. Remember, if you go to Kaggle, you will find a lot of useful data sets, not only data sets, notebooks on how you can see existing examples of data pipelines, courses, competitions if you want to put in practice. But yeah, and optional, I say this is optional because yeah, I'm using Jupyter Notebook, but you can use a Colab, a Kaggle notebook, directly just a Python script. That it doesn't matter. Oh, sorry. Before going to the last slide and thank you and everything, I will show you the code. So section 1, import required libraries. Let me close this. Let's start by importing all necessary libraries for all data pipeline. So pandas, remember, NumPy. I think actually we're not using this directly, but it doesn't matter. Matplotlib, Seaborn, and warnings. It's just for us to avoid some warnings that has scikit-learn and Seaborn. But don't worry, you can avoid also the warning parts. So at the end, all libraries import successfully. Step 1, remember, load that set from your CSV. In this case, the existing data set is on Kaggle. Remember, this is well for Philip. And well, I also downloaded already, and I have it here on a data folder, and this is called bi.csv. So we are going to read this pandas data frame and store it in this variable, which is data frame. We are going to print the data set. It's successfully loaded, and we are going to show some things like the shape and the columns. Also, the head function shows the first 5 rows of each dataset. This receives an input. We can show the first 10 if we change it as this. And the info, for example, for the number of students, features, data types, and everything. So let's run this. Oh, loading real students prefer what broke. Let me see. UTF. Is that with CSV UTF code can decode byte in position? Oh, I see. Well, I see this is because something here it's broken. But I think this is broken on purpose. Let's see. Give me a second. I'm going to fix with Copilot. Let's see what the output. Okay, perfect. Accept. It receives an encoding function. So great. So we have a number of columns: F name, L name, age, gender, country, residency, entry, exam, prep locations, to the hours, Python, and DB. The first 10 rows of the datasets look like this: Christina, Philip, Leo, the age, the gender, if it is male, female. We see also they come very differently. First, we find a female with an uppercase F, then another female with a lowercase f, then just an F, things like this. So we need to clean our data. Country: Norway, Kenya, Uganda, South Africa, Norway with an lowercase n. Residence: private, BI residence, many different ways to write this. Entry, exam values. And again, this is important because even though you can find these here, like some description, for example, if an name, first and last names, age, study, gender, this is something Kaggle provides. But again, not every data source it's going to have something like this. This is great, and if you have it, also take the chance to analyze this because it's really great. For example, Python DB scores for Python programming and DB skills, number of study hours, a key factor in student performance, previous education level, scores from an entry exam, potentially predictive of Python DB performance, current location, country of origin, gender, things like that, right? If you don't have it, well, that's a problem. Um, Also, this says this include a clean data set, but I don't think it's okay. This is an HTML, so that's weird. Let's not put that much attention. Let's return here to see the rest of the results. That set info. So 77 student records, 11 columns, and some information regarding the types. Uh, O type 6, integer 4, and float just 1. I don't know, I'm not sure what this O type is, but it doesn't matter. So we can examine the data structure and identify some quality issues from the data. Starting from a good thing that it's called info and describe. These two ones are really, really great, and one other reason why pandas it's also magic for understanding our data. Let's run this, and we will find that uh, data set information looks like this. Non-null count, it's for the full name, all are good. First name, last name, age, gender, country, residence, entry exam, previous educations, to the hours. Except for Python, all the rest looks good. So some static summary, it shows that we don't have any duplicates. We have all 77 rows, and all there of them are unique. Um, but we do have some missing values on Python. So statistical summary, it also gives us the count for all of the columns. Actually, if we add here of the describe, I'm going to say include all. And yeah, transpose, it's going to be great. If I do that, you will see full name, full name has a count of 77, unique 71 values, so there are some repeat numbers, names here. The top or the most frequent name is Emma, so it was repeated twice. There's no mean or standard distribution or mean value, because this is not a numerical value, right? This is not even categorical, but this is just plain text, right? Let's see, for example, with age. So the count are 77 values. All of them are unique. There's no top, there's no frequency, but here we do have more things about statistics. So the mean value, it's 35. The standard distribution variation here, it's 10. So they tend to vary for 10 years. The mean or the youngest people, it's 21, and in the first 25 percentile we have a normal of 27. The mode, sorry, the not the mode, the medium, it's 33 years. So you see how it's different from the mean. On the 25, sorry, on the 75 quartile, this is 42, and the max value it's 71. That means the oldest it's 71 years old. So we can see more information about this then, and this is great. Some of the missing values in the Python category, we have two missing values, and well, I think that's also great insights about this. So we already are identifying some issues that we need to tackle for cleaning our data, right? Transform. Let's clean now our data. For this, we are going to create a copy of the original data frame, and we are going to call this the data frame cleaned, right? We are removing some of the duplicate rows. Remember, in this case, we don't have duplicates, so that's completely fine. Uh, and we're also dropping them. The we well, let's run this. Also, we are for handling the missing values. Let me just make a quick correction here. What's happening? Age, the above exception has its age. Okay, yeah. It was uppercase age. Oh, yeah. Sorry. Oh, let me drink some water and clean my nose a little. I'll be back in just 1 second. Okay, yeah. Sorry, I'm back. Thank you so much for the wait. So the original shape looked like this. We removed 0 rows, remember, because there were no duplicate rows. That's fine. But I did add it for you to reference if you do find something, um, or you face a data set that do have to be cleaned this way. Well, you know now how. And for handling the missing values, the numerical cells are age and the income, for example. Um, no, there is no income. Sorry. Well, removing handle mixing values. Okay, it's weird. More robust to our liars than me. You see, um, you see why we're using the median, right? So our distribution it's in a way that we have a lower value that it is where it was h here. The lower or the minimum is 28. The mean, no, sorry, the it's 21. The mean it's 35. The difference it's not that huge, but the max it's 72, almost double of this. So what's happening there? It's that it the distribution is charged to the left, so sorry, to the right. So to avoid being charged more from one side of the distribution, we're using the median, which, as the comment says, handles better the outliers, right? So for the columns existing, it replaced the null with the median. We already covered this, and there's no problem with that. But again, we currently don't have any missing numbers in this. The missing number is in where it was. No, there's not here. This was here. The missing number, it's here on the Python. And in this case, same mean and the median, there are 5 points different. And the max, it's 98, where the mean is 28. So we do need to change these for Python. Oh my. And for categorical columns, we use the most frequent value, which is the mode. I already mentioned this. In this case, the one could be uh, residence or country, but since they are not missing any value, there's no reason to do it. This is just an example, right? That's why this is for city, but we don't have a city column, right? So again, you can have an example of how to do it in case you do need to change it, right? So handling missing values, fill two missing values in Python with the median. Uh, and step three, it's the handle outliers. We can use IQR method for the age, for example. So the quartile or quantile first, it's the 0 to 25%. Quantile 3, it's the 75%. And the IQR method, what it does, it's that it rests or it has the difference between these two, and it gives the lower and upper bounds for creating this. Um, this it's great to see in a box plot because we see what's outside these two quartiles. So things like the minimum and the maximum values are reduced, are removed, because that does not represent what we're trying to aim, which is the 50% of our data or of our entire data. So this is some a statistic, some statistic method that can be applied for removing the outliers. And well, once we do all of this, what we get it's that the original data set looks with like this of 77 rows and 11 columns, and we to remove the outliers from this, so the minimum and the maximum values probably, and so what happened here is that we reduce our data set in two rows. And don't worry, even if this is something that for us could affect because we have less data, this is totally something you can just comment, right? Right now, let's not comment that. Let's keep it as it is. And the point is to not have missing values after we clean our data. So once we have a clean data, we stick with that. So we transform with feature engineering. For example, we can create a category element. So if depending of the age, we can create a young, middle age, or senior. So not being a numerical value for the age, but a category. That's an interesting approach. So we do that. We create the age group based on the age, apply this category, and well, also uh, we don't have an income actually. So what we can do, it's gender, country, residence, study hours, create student type based on study hours. So we have hours, and we need to change, for example, in our previous, for study hours, how are the quartiles and the percentile. So study hours, the last it's around 144, the median is here, and it's not that far from the maximum. So let's copy these values and take them here. So I'm going to take them as, if it is less than 144, this is going to be low, else if it is greater than 150, this is going to be medium, and else this is going to be a high uh, performance student, right? So that's just how we create a new category, study hours created feature, uh, not about the income. This is not something we want to have. Note spending behavior. Target variable for high value customers. No. Standard scale. Okay. Here. So this is 3. Normalize features for some numerical columns. For example, the age. This is not income or features amount. But for example, for Python, what else? Some numerical features, entry exam. Oh, uh, Python DB. What else? Gender, age. I think that should be all. Yeah. So we're applying standard scalar for that. So once these are clean, we add an age normalize, Python normalize, entry exam normalize, and DB normalize, thanks to the standard fit scalar. Uh, and we encode the category variables. We create the label encoder, and we apply things for example, not gender, but residence and country. Just residence. And here code. Perfect. So this is what I mentioned before. Norway it's going to have one value, Denmark is going to have another. If it is private or if it is via a residence or if it is songs or this word, I don't know what it means, but we can continue with that. Right, display the new features and do that feature engineering. Oh, error on study hours. Define. Okay, let's see here. Study hours, clean. Okay, yeah. Study hours like this. And here, this is age. There is no income. This is study hours group. We need to rearrange residence code, country and code, whether there's, for example, age normalized or age. Let's actually remove all of this. Age normalize all of these, find a normalized example. Great. So they look like this. Now we have study hours group, high, medium, low, depending on how many hours they study. Residence encoded, so 4, 4, 5, for example. Another thing we can do is instead of hey, we can run sample, and this is going to take a random sample of the elements and saying we can give the number of desired elements. So we see a lot of residence and code are 4. In country codes we have at least 12 different countries, edge normalized, Python normalized, entry exam normalized, and DB normalized. This is for the standard scalar. And you'll be wondering why we do that or why we apply to this. Well, because these are numbers, and some of the portion of these numbers are way too big or way too low. Imagine, for example, comparing the study hours that are around 150, 160 against the age, which are no more than 71. Um, we have examples, for example, for the entry exam, and what we are trying to do here is try to reduce the probabilities for the model to interpret some feature with more importance based on the based on the size of the value, sorry, of the value of the element. So it's in this case it doesn't think 48 in the age it's less than 148 in study hours, for example, because they are normalized and they go from like -1 to 1, or, well, less variety of numbers, right? Uh, as a low range. So that said, finally, we need to load and save the clean data. Right now, I'm not going to run this because I don't want to upload this to GitHub. But well, yeah, I do want. I think it's important. So inside data, clean. No, let's call this out, and I'm going to git ignore that out folder. Uh, yeah, perfect. So it's out clean data customer, not customer, clean data. Out file name, output file name. Okay, let's do that. What is this? Okay, maybe out. Perfect, it's completed. Yeah, now we have the clean data using F name, L name, age, gender, country, study hours, all ones that we mentioned previously, encoded country, science, and things like that. Then we can sum it, we do the exploratory analysis, we change the values here for what we are doing. Um, Same here. We are applying target variable distribution, but for the study hours, group. No, what was the name? Yeah, study hours group. And also each group. No, we don't have this. We have residence encoded and country encoded for the categoricals. Right, let's see how they looks right now. So we basically apply or did the same that we mentioned previously, but right now we're making sure that these apply for our specific and new and clean data, right? Now we create some visualization for the age distribution. Let's remove the income distribution. Let's call these study hours distribution. This pending should be replaced for the Python normalize. Normalized distribution, general distribution. No, this is the normalized distribution. CD distribution. No, this is for country distribution. And finally, city. No, residence distribution. And let's see if we managed to do this without errors. Okay, there's a problem here because we don't have age. Normalized. And we can see how they behave. Customer data analysis dashboard. Okay, let's also call this different. Oh, sorry. Student data analysis dashboard. Students. So there's a lot of occurrences of the 8 number country. We will have to decode it to see which one it is. Also, load distribution for 1, 2, and 3 categories in the customers by residence. Python normalized cohort and study hours are on the right. So normally, a lot of our students do spend more than 150 hours, and a lot of the Python normalized distribution is here, so high values. I think the lower skills are on DB, and same with the age. We tend to see more young people than old people. So great. And finally, we We can delete this correlation thing. It's fine. So we apply the modeling. So let's try to apply that really quick because we're about to finish. Okay, let's also delete the model evaluation and prediction. Okay, no, yeah, here. So machine learning, feature columns, we want age, normalized, country. Also, what we have, it's Python normalized, DB normalized. What else? Oh, sorry. Uh, uh, um, Entry exam normalized. Um, Study hours group. Study hours group. Residence encoded. Country encoded. Great. So what we try to achieve is the no sorry, we tried to achieve this to the hours group. So based on everything else, we would like to get how many of these hours or which group of students are they. Also, we have a gender one, so let's take a look to the gender. Train split, perfect. Let's delete these two. That is splitting, shape, distribution. Okay, great. Train the model. Oh, some of these fail. Random forest, 100 estimators, no random state, max depth, that's fine. Okay, I will delete all of these just to have the maximum estimators as this. Train the model, train fit, making predictions, predict test. What happened then? Could not convert string to float mail. Oh, one thing we probably were missing. It's yeah, we can delete the. I mean, this is not going to be a perfect prediction, but the intention is just to give an example. If you want to see a better prediction and more accuracy, check the other statement, the previous the previous sessions on the data competition on Kaggle. This is just for you to have an example of how this worked. And well, all it was trained and predictions were generated. The feature importance, it's how good are in Python. Uh, what was there not on the entry exam. And the last one, it's the resident type or the country where they come from. The age, it's not also that important. And well, this is the result. Finally, I think it's worth saying that I'm going to be pushing this to a repo. Um, it's fine to have slides. Git ignore. I'm going to add the PDF, don't worry. I am not going to include the CSV, but I do, I am going to add the data processed here. Well, yeah, I'm going to include that. I'm not including the output because you can run the experiment and gather that yourself. I'm going to include this, the README, and everything. So git git commit base and git remote add, and I have that repo here. Perfect. So the repo is this, and here you have the steps and everything. So I share it with you. Also, if you have any questions right now, it's time. Um, Ready to build your own data pipeline. Well, and also I include the repository. And in the repository, there are the slides. So thank you so much for joining me in this session. And remember to join Rosendo for Gemini Studio. And please, please, please don't forget to share your feedback via this link. It was my pleasure to be part of this Global Hack Week Data Week. And thank you so much. Remember, we have more Global Hack Weeks coming up. If you want to know or even pre-register, go to ghw.mlh.io. And well, that's all. Again, thanks so much. And I'll see you in the next one. Bye.